Alright, so there's a few different factoring techniques that we're going to cover. Hopefully some of them are familiar, maybe some of you are more comfortable with one technique versus another one, but we need to get very, very comfortable with identifying which type of factoring that we're going to have to perform based on the way an equation works. So if we take a look at our first example, 6v plus 60, notice how this only really has two terms in it, okay? I want you to look at those two terms and think about, in terms of factoring, is there some number, aka factor, that we could pull out or divide out of all of those terms? Go ahead, Emily. 6. Okay, so if you were to essentially divide a 6 out of every term, we are what's referred to as factoring or pulling that 6 out. When we pull the 6 out, we have to then write, well, what's left over after we do each division of 6. So notice how in the first term the 6's would cancel, so we're left with a v, just 1. And in the second term, we're going to be left with a 10. Do you know what this type of factoring is called, this technique? When you pull out the largest number or sometimes variable possible? We're used to doing it, but do we recognize or know the name or type? What do you think, Marie? Greatest common factor, aka GCF for short. Okay, greatest common factor. So what's nice about this greatest common factor technique is you can make the numbers kind of easier to work with. Notice how we're now working with a 6 and kind of a 10 if you just were to look at those number values instead of a 6 and a 60. So by pulling out that greatest common factor, you're kind of simplifying or making the numbers smaller, more easier to work with. Okay? What about in the next case? Is there a GCF, a greatest common factor, that we could essentially divide out of both those terms? Good, Marie? We could do an 8. Okay, so notice how 8 would evenly go into 8 and 48. Okay, those numbers are coefficient terms. But we can also pull out a variable because this term has 2 x's, this term has 1 x. All in all, the most we can pull out of both of those is just 1. So we're going to divide both terms by 8x, which means that's what we're pulling out. So we need to write what's left over after we do that division. So in the first term, the 8's cancel, and one of the x's would cancel, so we're just left with 1x. And in the second term, 48 divided by 8, we got 6. And notice how the x's would go away, so we're just left with a 6 there. Okay? We're used to that type of factoring. Okay? Again, this is called GCF. So the 8x in this case is the greatest common factor. That's the largest item or term that you can pull out of everything or divide out. Okay? Some of you are probably very familiar with, well, what if we have 3 terms like this? Okay? Anyone want to give this one a shot if you're kind of skilled in your factoring techniques? Go to Rebecca. Perfect. Now, how'd you get that?
I just tried to find 2 numbers, like 2 multiples that add up to 8. Well, 2 of 8 multiples that add up to 9.
Okay. So we kind of have a little number game that we have to perform in our head to help us with this type of factoring. Sometimes you might hear me refer to this as I am factoring. The reason I phrase it like that, to help me kind of remember what's going on, is if the number in front of your x squared term is a 1, you see how that kind of looks like an I? Okay? If that number out front is a 1, you got to think about 2 numbers that multiply to 8 but add to 9. It's a little mind game. So if you wanted to actually take the time and think about all the numbers that can multiply to 8, you have 1 and 8 and 2 and 4. Those are your only combinations. So out of those 2 combinations, if you were to add the 1 and the 8 together or the 2 to 4 together, your goal is to get 9. Okay, clearly the 1 and 8 is the only pair that works. right? So in terms of your factors, you have an x plus 8 and then an x plus 1. Okay, the x comes from the variable being used in the expression. Do you see why I call it I am sometimes? Okay, I think that helps. All right, so we have a GCF technique. Sometimes this one is what's called a trinomial technique because there's 3 terms. All right. What about the next one, x squared minus 16? Notice how this one has 2 terms, kind of like the first 2 examples we had, but there is not a GCF that we can pull out. What do you think, Tori? Okay, how'd you get that? Oh, we know the name. All right, difference of squares. Perfect. All right, what does difference mean in math? You have some difference quotient product. Difference is, yeah, subtraction. All right, so you have to be subtracting 2 perfect squares. If this was an addition, you would not be able to factor it this way. Okay, it has to be subtraction. That's why it's called difference. So Tori, how did you know it was x plus 4 and x minus 4? Perfect. All right, so if you were to take the square root of the first term, notice how the square root and a square, those are inverses, they cancel each other out. So the perfect square of x squared is just x, and if you were to take the perfect square of 16, aka the square root, you would get 4. All right, so in order to get that subtraction or that difference idea in there, one of your factors has to be a plus and the other one has to be a minus. Are we familiar with that technique as well? Nothing new so far? Okay, let's try the next one. So notice how this one is set up as 2 terms and it is a difference, but 3 does not have a perfect square root and neither does 75. So this one is kind of set up like a difference of squares factoring example, but it's not exactly going to work, which means maybe we can try one of the other 2 techniques as terms of factoring. Yeah?
Negative 75 by 3.
Let's take out a GCF. Okay, if you take a look at those 2 terms, think about, can you make those numbers different? Can you make those numbers smaller or easier to work with? We can divide a 3 out, so that's our GCF. So we're left with x squared minus 25. All right, so there's one factoring technique. We use the GCF. Can we continue? Can we use another factoring technique? Can we keep going? What do you think, Hannah? Right, so now this is a difference of squares. X squared is a perfect square, 25 is a perfect square. So if we were to use the difference of squares technique on that kind of leftover factor, we would have an x plus 5 and an x minus 5. Sometimes you might be able to do more than one technique. You just want to keep going until you can't use any more. Okay, try to use as many as possible. We hanging in there? All right, so now we're going to get into the good ones. So if you take a look at this one, we have 3 terms, aka a trinomial, right? But this does not fit the kind of I am format, right? Notice how the coefficient, the number in front of the x squared, is not a 1. Okay, this time it's a 6. So we cannot just think about what multiplies to 2 and what adds to 7. Unfortunately, that format's not going to work here, or that technique. Could we try a GCF? Could we pull out a number that can easily go into all 3 of those? No. All right, so GCF's out. The kind of I am trinomial is out. Definitely not a difference of squares because we're not even subtracting 2 terms together, right? So this is going to be another unique way to factor. Are we familiar with how to factor this trinomial when this number is something other than 1? I've seen a lot of different ways to go about it. I'm just curious as to what you're familiar with. And I'll show you the different ways and you can choose which one you're most comfortable with. Yeah. Okay. You're on the right track. Go ahead, Tori.
So you're multiplying A times C.
Uh-huh.
And then you find the factors of C that add up to B.
Perfect. Okay, so just in a standard form quadratic equation like the U-shaped parabola graphs we've seen so far, it's typically ax squared plus bx plus c. A, b, and c are always going to be numbers. So what we're going to do is take the a term times the c term, which is this case, or in this case is 12, and our b term is 7. So kind of similar to the I am format, we want to think of two numbers that multiply to 12 but add to 7. Can we think of those two factors? Yeah. 4 and 3. All right. So from this point, there are two different methods you can kind of use to help you factor this one. I'm curious as to where you guys want to go from there. Go ahead, Tori.
I would do 6x squared plus 3x, and then have plus 4x plus 2.
Okay, that's one way. Is someone familiar with a different way? You may or may not be. Bless you. Okay, maybe we'll go over this way first. What Tori is hinting at here is a method called grouping. Notice how we have 4 terms now, right? We went from having 3 at the very beginning to 4. So what Tori did is, instead of having a 7x in the middle, she simply used the 4 and the 3, because don't those add together to give you 7? If you were to combine those, you would have the 7x that you started with. Okay? Tori, do you want to continue, or yeah, keep going. Go ahead.
So you group together the 6x squared with 3x.
Uh-huh.
With 4x squared together.
Okay.
And then for 4x squared. And then you're going to take out GCFs as well. So I took out 3x from the first one.
Yep.
And then I got parentheses 2x plus 1. And then I took out a 2 from the other side and got x plus 1. Or 2x plus 1.
Yep.
And then you take the stuff on the outside and put it in its own parentheses, which gives you x plus 2. And then since the other two match, it's 2x plus 1.
Wonderful. All right. Perfect, perfect. So, once Tori had her 4 terms, she grouped, and that's why it's called grouping, she'd group the first 2 terms together and the second 2. Now, you might be curious, well, does it matter if we write the 3x first and then the 4x second, or can we switch those? Okay, the order doesn't matter. This could have been a 4x and this could have been a 3x, and it still would have worked out fine. Okay, so the order doesn't matter when you put those in. Once you group them, you're going to look at each individual group and see if you can pull out a GCF. If you look at the first group, between the 6 and a 3, you could pull out a 3, and between the variables, you can pull out an x. After you do that, you're left with 2x plus 1. From the second group, you can pull out just a 2, and notice how you're left with a 2x plus 1 again. In order for this grouping to work, your leftover factors must be the same. They have to match. For instance, if this was 2x plus 4, we would not be able to go any further because that does not match 2x plus 1. Okay, they have to be the same group. So since these match, one of your factors is the 3x and the 2, the GCFs that you pulled out, and the other factor is the 2x plus 1. Is this kind of the method we're most familiar with for this type of factoring? If you're comfortable with that, go for it. Okay, so that's, you can use grouping to help you with that. I'm going to show you the way I was taught, or how I do it, how I'm familiar with. You might like it a little better. If you want to use it, it's fine. If you don't, you're not going to hurt my feelings. Okay, I call this one divide and slide. Okay. So we're still starting this process out the same way. We're still doing the a times c to get 12. We're still doing the b of 7. Think of 2 numbers that multiply to 12, add to 7, we got 4 and 3. Okay, it starts out the same way. instead of rewriting that middle term to get 4 terms, what we're going to do is simply write x plus 4 and x plus 3 with those 2 numbers that we found. Okay? Now the reason this is called divide and slide is because once you write down those 2 numbers, we are going to divide both of those by the a value, which was 6. Can we simplify these fractions that we have now? Can we simplify 4 over 6? That would be 2/3, right? And if we simplify 3 over 6, that would be 1/2, right? Okay, so that's the divide part from the name. Okay, the slide part comes from this denominator. You can slide that number out front as a coefficient attached to the x. Notice how this one would be 3x plus 2, and this would be 2x plus 1. Isn't that the same factors that Tori got using grouping? Okay, so you have 2 methods, 2 techniques to factor this more advanced trinomial. You could either do grouping, if you're most familiar with that, if you're comfortable with that, use it. If you prefer divide and slide, use it. Okay? All right, let's go ahead and check out our next one. What do you want to try to do? Does this fit? We have 3 terms, right? So does it fit the I am format, the easier factoring type? No, because this is not a 1, right? What do you want to try, Marie? All right, so some of you might be thinking, oh, well, there's a number out front there. Okay, I can immediately do a times c. But if you tried -6 times 60, that would be -360. Isn't that a very large number to work with? So instead of working with large numbers, try to see if you can make them smaller. Let's try to pull out a GCF. So Marie chose 3. I'm going to add something to this. What if we pulled out a -3? Do you know why? Were you going to say that?
Yeah.
Okay, it's okay. Do you know why I want to pull out a negative as well? Can you take a guess? Go, Tori.
Can your first term never be negative because it'll mess up when we go through the...
It can be negative. It's just more, it's easier to work with if it's positive. Okay, it can be, but it's just easier to work with. Okay, so the fact that this is a -6 first term, we're going to pull out that negative to make the factoring a little bit nicer to go through. All right, so let's go ahead and divide everything by -3. All right, so there's one type of factoring. We did GCF. Let's now look at the leftover piece we have and see if we can continue to factor. So now that we have a 2x squared plus 3x minus 20, where might you want to go from there? It's a trinomial, so you either can do the I am technique, or you can choose the grouping or divide and slide. Which one fits this one? Good, Marie? Divide and slide, or grouping, okay, whatever you're more comfortable with. Notice how this is a 2, it's not a 1, so it's definitely not the I am format. So if we were to do a times c, this time we have 2 times -20, which is -40. Isn't that a lot easier to work with than -360 that we had before? Okay, so that GCF is your friend. It's going to make your numbers easier to work with. And our b value is 3. So we got to think of 2 numbers that multiply to -40 but add to 3. This is a little mind game. It might take you some time. What do you think? 8 and -5. I like it. Okay. Now, do you guys want me to go through the grouping and divide and slide again, or do we want to do just one? Maybe we'll do both, just so you can see which ones you like better. Okay? Okay. Maybe we'll do grouping over here. Okay. So when we look at the expression that we have now, we pulled out a -3, okay, that was our GCF, and our trinomial, instead of having a 3x in the middle, we're going to write 8x and a -5x. It doesn't matter the order, okay, you just got to write both of them. So maybe we'll do 8x minus 5x, and our last term was a -20. Notice how you went from 3 terms to 4. So we're going to group the first two, and we'll group the last two. What can we pull out of the first group? Go, Tori.
2x.
A 2x. So we're left with an x plus 4. Okay. Now the goal with grouping is that if this is an x plus 4, we got to make sure we get the same leftover factor from the second group. So what can we pull out from a -5 and a -20 to make it an x plus 4? Rachel? A -5, perfect. Notice how you're dealing with negatives and you're trying to make it a positive, so you got to pull out a negative as well. So we're left with x plus 4. They match, right? Perfect, perfect. So we have the -3 GCF from the very beginning. That never goes away, okay, because you already pulled it out. The GCFs we pulled out from the groups was a 2x and a -5. And then the matching factor that we have is an x plus 4. Notice how we never lost the -3. Okay, it's always still out front from the very beginning. All right, there's grouping. Let's go ahead and try the divide and slide. Okay, so again, we're not going to lose that -3. That's still out front. I'm going to write two factors. One of them is an x plus 8, and the other one's an x minus 5. Okay, that 8 and -5 that Evan found for us earlier. So the division part, what are we going to divide by? Good, Maddie? Not necessarily -3. This was our GCF. What do you think, Sarah? 2. Okay, 2 is that A value. We're going to divide by the A value. So divide both of those by A. Let's go ahead now and simplify our fractions. 8 divided by 2 is 4, but 5 divided by 2 does not simplify. So let's see if we can slide anything. If you were to turn 4 into a fraction, wouldn't it be 4 over 1? And if you wanted to kick that 1 out front, that really wouldn't change anything. So the x plus 4 is going to stay, but you can slide the 2 denominator from the other factor in front, and we get 2x minus 5. Same factors, right? They match. They're just in a different order, but order doesn't matter when you multiply. Are we starting to have a favorite? Yeah? Do we like the divide and slide? Maybe. Some of you still might prefer grouping. That's completely okay. Okay, but you have options. All right? Let's go ahead and check out the back. All right. So notice how these two equations are a little bit different. In this case, our trinomial or binomial, in this case, two terms, actually equal something. Okay, these are equations because you have that equal sign in there. So since these are equations, we're going to try to solve for x. And we're going to use some factoring techniques to help us do that. Okay, so if you take a look at your first one, how might you want to try to factor that? First of all, can we use a GCF? Can we pull anything out to help us make the numbers smaller? No. Is it a difference of squares? No, because we have 3 terms. Does it fit the I am format? No. So our only other option is to do that either divide and slide or grouping technique. Okay, whichever one you're more comfortable with. In either case, they always start out the same. We have to take A times C, which would be negative 12, and we need to add to negative 1. Can we think of those two factors? Those two numbers? Good, Rachel?
Negative 4 and 3.
Negative 4 and a positive 3. Good. Alright, now for time purposes, would we prefer that I show grouping or divide and slide? Because I'm not going to keep doing both. Which one would we prefer to see? Yeah? You want divide and slide? Okay, let's go ahead and do that. So we have two groups, x minus 4, x plus 3. Let's do the divide part. We're going to divide by the a value, which was 6. Let's go ahead and simplify those fractions. We got 2/3 and 1/2. Now comes the slide part. If you have to do that, we're going to slide out the 3 and slide out the 2, okay, the denominators. If you were to go through the grouping process, you should still get the same two factors. Okay? So when we look at the equation, these two factors are how the left-hand side kind of simplifies or rewrites itself, but we still have that's how the left-hand side rewrites itself. We still have a right-hand side. This still equals 0. All of that factoring technique was only for the left. Okay? So with this equation, and now we have these factors, we're going to try to figure out our solutions for x. Any ideas where they might come from? What do you think, Rachel?
You break up the parentheses, so you would do 3x minus 2 equals 0 and 2x plus 1 equals 0, and then you would solve for x.
Do you know why you can break them up? That's great, but do you know why?
Because
They're both a possible solution. Okay. Take a look at this. Aren't you taking this factor times this one? You're multiplying them together, right? And you most certainly know that your answer is 0. If you're multiplying two things together and you know your answer is 0, what do you then must know about one of these two factors? What do you think, Tori? One of them has to be 0, right? In order to multiply two things together and get 0 as an answer, one of your two things that you're multiplying has to be 0. So this is our way of checking it. What if this factor was 0? What if this one was 0? So since we have two factors, we should end up with two solutions, okay, two values for x. So if we solve the first one, you can add the 2 over and divide the 3. And the second one, you can subtract the 1 and divide the 2. So we have two solutions for this particular equation. If you were to plug in 2/3 into the very beginning, you would get 0. And if you plugged in negative 1/2 into the very beginning, you would also get 0. There's two numbers that actually work. Okay? Let's go ahead and try the next one. So this one's a little different, right? This one does not equal 0, but our goal is to get it equal to 0. That way we can break it up like we did the first one. So how might we get this equation equal to 0? Good, Brianna? Let's go ahead and add it over. So you may have to do a little bit of rearranging to get the equation equal to 0, but it's still possible. All right, let's try to factor. GCF, can we pull anything out? Shaking our heads, no, that's good. Does it fit the IM format? No, because that's an 8, right? Difference of squares. Definitely not. All right, so we're narrowed it down to either the grouping or divide and slide, whatever you're more comfortable with. In either case, they start out the same way. We got to do A times C. We got 24. Add to B, -10. Can we think of those two factors? Multiply to a positive 24, add to a -10. What do you think, Evan?
-6, -4.
-6, -4. Awesome. All right. Do we want divide and slide again, or do we want to do grouping this time? You want to do grouping? Okay, let's do grouping. So grouping, we're going to use the -6 and -4 to rewrite that -10. Again, it doesn't matter the order you write these. Now that you have 4 terms, we're going to group the first 2, group the second 2. What's a GCF we can remove from the first group? Go ahead. A 2 and an x. Good. Okay. So we're left with 4x minus 3. Now we have to get our second group to match that. Notice how it kind of already does, but not exactly. So what do we have to remove or GCF from the second group? What do you think, Sarah? A -1. We gotta switch those signs. So removing a -1 would do that. Okay. So our factors, we have the GCF numbers, the 2x and the -1. And then the matching factor group, 4x minus 3. So now that we have our factors and we know the answer should be 0, that means we got to figure out, well, when does the first factor equal 0 and when does the second factor equal 0? Because one of them has to be. We don't know which one, so that's why we're going to check both. In the first one, we can add the 1, divide the 2. And in the second one, we can add the 3, divide the 4. We doing okay? All right. Factoring coming back to us a little bit. All right. Tomorrow we're going to take a look at the bottom example, and we're going to use a calculator to kind of help us with that one because it's going to be slightly different. All right. So if you want to try some homework problems tonight, you can. We've done most of the section already, okay? But I think you should be able to do most of the first page of that homework assignment. Deal? All right.